Hello, everybody. Welcome back to another episode of Today's Weather Tonight. Here, as always, I am your meteorologist for the evening, Cloud Hudson, and I'm going to be bringing you all of tonight's top weather stories. We are going to dig into it. What just happened in the past week? I was gone for a few days because I had a lot of work I needed to do, some creative work, some lighting design work for a local production of the Nutcracker. So I was happily employed in my chosen field, which is a miracle of itself, but definitely a blessing of this holiday season. We also had the winter solstice, which was, I think, a good time for reflection, as it always is for me and other people who observe the solstices and equinoxes as markers of passing of time throughout the year, that we are moving from one season into the next. This is kind of the peak of the dark times. We are now growing in light. We have had the longest night of the year, the darkest day of the year, and now we are moving back into bringing light into this world. So that's why Christmas is right after the solstice and not before or on it, because Christmas is the bringing of light into the world. Yeah, that's all I can say about that. Let's get started talking about weather. Let's see. Notice that I say a lot, and I'm trying not to say that too much anymore, but I'm not great at breaking that habit. Also, I did cut my hair. I don't really know what shape it is or what it's trying to do. I guess I could get it, touched up somehow soon here. Okay, let's talk about weather headlines. First one that I liked seeing was early morning earthquake reported in Western North Carolina. We had a earthquake, a 1.8 magnitude at 0 kilometers depth around 4:25 a.m. today in Dillsboro. That is 47.3 miles west-southwest of Asheville. And the earthquake itself was 5.7 miles southwest of Dillsboro. So that's really cool. Actually, I'm going to open the location of it so we can see exactly what area this is near. Okay, so it was in the Nantahala National Forest, just near the Brushy Fork Mountain. This is right on the border of Jackson County and Macon County, if you know where that is. Kind of like up towards Panther Ridge, at the head of Panther Ridge, in Micah City Creek and Micah City Road. Anybody who knows where any of that is, if this is your people, your kin, your folk, your area, then this is up near Buzzard Roost Ridge, Mason Mountain. It's on the mountain ridge where the Brushy Fork Creek and the Rhoda Branch and Micah City Creek all come off of this mountain right here. Betty's Creek Road and Betty Branch all come off there. This is the Cowee Mountains, so named for Coweta, or Coweta is in the area. This is also due south of Cherokee, and it's part of an area that should be part of the Cherokee Reservation, I think. This is exactly, okay, so you see this corner right here? This should have been a big diamond. Actually, all of it is Cherokee or Chilagi land, and it should all be Cherokee reservation, not reservation. There should be like a reservation of the invaders, if anything. But anyway, this is like kind of near the original. It was supposed to go out here and be a big square, big diamond, I think, of one of the original reservation treaties was supposed to be a big diamond, but it's gotten chipped into by settlers wanting to take it, and basically violating their own treaties. This is the reservation with convenient road carved out through it. What is it but the Blue Ridge Parkway? Just to make sure that we don't let people have nice things. What am I talking about? I think it's cool that this is where the earthquake happened. This is a very energetically active spot. We are northeast of Franklin, and there are really high and really low energetic spots here. Both areas that are really good for your health and very bad for your health. That's all I got to say about it on this at this current juncture. But yeah, we are pretty close to the triple point of, is this Swain County right there? This is, which one? Lake Fontana's right there. This is Graham County. This is Graham County. I think this is Swain County. And this is Macon County. Where did I just see? Oh, yeah. And this is Jackson County. Really rude to name this county Jackson County, I think. That's kind of fucked up. So, yeah, really cool. So there was an earthquake. There's not much earthquake activity out here, so that's really neat. Shining Rock is over here. That's also another really active area. Let's see. Do I have my Google Earth? I'm not going to pull up my own Google Earth map on here because I've got sites of important stuff mapped out. But I'm not ready to share that. Anyway, let's go to our next story. Let's go to the story that's in North Carolina again. Word from the Smokies. I-40 rebuild offers rare opportunity for wildlife conservation. So TLDR on this is that since a bunch of the, I don't know if you guys know this, but a lot of highway, stretches of highway, bridges, areas that pass near rivers in Western North Carolina and Tennessee have been completely washed away, like you see right here. I made a video as Helene was setting in of how a neighbor's property showed their creek had a little mini washout that was just like this, where there was a little bit of subsidence, where a little bit of a mini earth slide, and then the new water rushing there carved out a huge new curve in the creek, and it washed out the retaining wall of the creek. That's one of my videos from back when Helene was hitting. This is like that on a big scale. And in that video, I think I do talk about how this is probably going to happen on a big scale. That actually happened here. So we need to replace over 300 sites. There's over 300 sites of these, let's see, 185 road closures, 140 bridges in need of replacement. Oh, nearly 8,000 sites damaged. 8,000 sites. So there is this group called the Wildlands Network, who this guy is a part of, a scientist part of them. who has been working with the NCDOT for years to try to get wildlife passages put into the designs of bridge and road repairs. How this is related to Helene is that he says that if you put in culverts under the bridges that are big enough to withstand another Helene type event, culverts are these big things that you see the bear standing in right here. If you make them big enough to withstand epic biblical proportion floods, then they will also be big enough to allow bear and deer and all kinds of critters to pass through them. That's basically what the wildlands people want done. They don't necessarily want like a overpass bridge for animals to walk over the highway, although that would be cute too, I guess. They're saying that if they plan for disaster when designing the repair of these roads and bridges, then it would have the effect of preserving the abundant biodiversity of one of the most naturally biodiverse regions in the world. So as we replace these big chunks that have gotten taken out, why not go ahead and rebuild them with the priority of planning for long-term, expecting disaster, and protecting wildlife. And protecting wildlife is a great way to prepare for disaster, because having a biodiverse region and a lot of rich plant and animal life in your region does in fact help you withstand these kinds of disasters. I know that it doesn't look like we fared well in the face of this hurricane, but it could have been a lot worse. And the places that were the most devastated were the places that were like people were living. The nature was also devastated, but if you can see here, the place where it washed out isn't where you see trees here. It's the non-tree area. Anyway, what I'm saying is it would be good to expect the worst to happen and have the animals taken care of at the same time. Speaking of the worst to happen, is this a scary headline or what? Massive fireballs spotted streaking across U.S. skies, and it came from China. Well, that sounds more scary than it actually was. This was a cluster of fireballs streaked across the southern sky Saturday night. I already played the ad, and it's going to make me watch it again. Which alarmed a lot of people in the context of the drone sightings in New Jersey. But this wasn't anything like that. This was actually a satellite that was out of commission, re-entering the Earth's atmosphere and burning up upon re-entry. So it was a Chinese satellite. So while that sounds scary to people who are xenophobic, it was just a Chinese company that Space Eye or Space View or something like that, that had their satellite that they weren't using anymore up there, and it was allowed to re-enter Earth's atmosphere. And it is burning up in the atmosphere because that's what they do. That's what things naturally do on re-entry into the planet. You got to try really hard to get things to not burn up on re-entry. Space View is the company. So yeah, it was harmless. This is just space junk burning up on re-entry. And actually, you want space junk to enter the atmosphere and burn up, because if it stayed in rotation around the Earth, it would be contributing to the massive pollution, space junk problem up there. We're creating a big dome of metal crap up there that is possibly doing some interference with the way the Earth interacts with interplanetary space. Speaking of which, NASA's Parker Solar Probe gears up to touch the sun in a historic Christmas Eve mission. So, in 2 days, Christmas Eve, this space probe right here is going to get closer to the sun than any probe has ever gotten before. We won't get the data from that until the 27th, and we probably won't get images from that until January. But this is going to go into the sun's coronasphere. It's going to cut through plumes of plasma. It is thermal protection up to 2,500 degrees Fahrenheit, including a heat shield and white, is it ceramic? White coating that reflects heat back into the into space. Maintaining instruments at room temperature, even as the heat shield itself reaches 1,800 degrees Fahrenheit. So this should reveal how the corona is hundreds of times hotter than its surface and why. Or that's some things we've learned recently. There's a dust-free zone near the sun where heat vaporizes cosmic dust. We have tracked solar wind. This one's trying to enhance our understanding of solar wind, which will improve our solar wind models, which is a great news for anybody keeping up with solar events. Unveil how solar activity impacts phenomena such as the northern lights as space weather events, informing design and protective measures for future missions and technology infrastructure. So this is also named after Eugene Parker, the guy who Parker spirals are named after, and we've talked about that in the solar weather segment of this show a little bit, where those are the spiraling bands of consistent elevated solar wind speed that spiral out from the sun, around the sun, from specific places on the sun's surface. Like its arms that whoosh around it. Let's see. Another one. More than 170 snowboarders and skiers were rescued after Colorado's ski lift cracks. So there was a crack in the ski lift at some point, and the system automatically, instead of letting it go to failure, it automatically shut itself down, and everyone had to be evacuated, 174 passengers and their ski gear. But apparently, Ski Patrol has trained extensively for this, so they knew how to do it. Nobody was hurt. And the resort still had 21 other lifts open. So never you fear that these skiers and snowboarders didn't get to have their fun, because they did. It was just not on the one where this particular gondola happened to be. So that was pretty cool, kind of scary. But yeah, here's some video of it. You can see it at Colorado Winter Park Resort. This is the ski lift teams going into each gondola and using ropes, lowering people down via a little rope outfitted with a chair for the people. And they also roped down all the people's gear. I guess they all had to hike back. Or something. Speaking of dangerous shit, FAA is investigating after several drones fell out of the sky during a Lake Eola holiday show. This is near Orlando, Florida, where in the middle of a Christmas show that was like for a family-friendly outdoor celebration of Christmas, drones malfunctioned and started falling out of the sky. I think from what I listened to in this story, it said that like one malfunctioned and went haywire and then knocked others down as it went down, which could have caused a chain reaction. But it looked like the show was going fine up until that point. And these reporters did find a family whose child was injured by one of the falling drones, although the local fire department said that only one person was taken to the hospital with minor injuries. So that just goes to show you stuff. It just goes to show you that you do need to go out there and get some boots on the ground in journalism, because this kid had to have open heart surgery. Look at that. I mean, it's scary when the drones that we have here can't even handle doing a normal light display. And possibly there are drones all over New Jersey that could just, they're not a threat, but they could fall out of the sky at any time. So I think this definitely feeds into people's fears about drones. This is totally justifying people's concerns when they're like, I don't care if it's not aliens and it's not a foreign country. I don't give a shit about all that. I just don't want the drone to fall out of the sky and hit me. That's probably a decently valid fear. Now, all the other fears are probably, we don't have enough information to figure out if those are valid fears or not, but they're probably pretty good guesses of what would be scary. Speaking of scary and cool, there's some lava footage that's been released of the April eruption. This is the one that happened leading up to the eclipse season in April of this year. This is recently released footage by somebody who was there. Now, this is a good use of drones, because this is drone photography. And look how cool this is. This gives us great insight into the physical mechanisms, the fluid dynamics of how lava works. I'm certain that volcanologists have known this for a long time, but the more you can watch the stretching and pulling and cooling and cracking of the lava, the better you can understand how the lava works. You can see bubbles forming underneath this molten rock. Imagine molten rock bubbling and like having a surface tension where the bubble doesn't crack in it. Like, it's fascinating to see these little like bubbles come up and steam burst out. You can really like feel the texture by looking at it. You can like, you shouldn't touch it, but you can imagine what it would feel like to touch a material that has this viscosity and texture. It's just so cool. I love fluid dynamics and watching this Earth form. This is the formation of Earth. The rock solid Earth that you think you're just standing on every day was at one point liquid like this, and has only become hard because of certain conditions it's existing under. Under any conditions, it could always be molten again. So remember that. Everything you think of as hard, tangible, and immovable is always up for liquefaction. Okay, speaking. Oh, shit. Shh. I said mute. Okay. I'm going to turn the volume down too. That was crazy loud. Okay. Speaking of which, let's go look at the volcanoes today. Sakurajima volcano. Ooh, look at this banding of beautiful cumulus clouds coming off in like, these look like, oh, fuck, what's it called? It's the Fresnel diffraction, not Fresnel. It's the, the target-shaped interference pattern rings that come from a point source. Poincare, who diffraction rings. Hold on. Wait, there was a 8.7 solar flare. Was that recent? No, this was not recent. Why is space.com only putting that up 2 days ago. Okay. Erie disk. That's what I'm talking about, I think. Fraunhofer diffraction. That's what I'm talking about. Look at this. Doesn't this look like Fraunhofer diffraction just a little bit? Yeah, this is the diffraction of waves from a of light waves when it is scattered by an obstacle. Light and dark bands are often seen at the edge of the shadow. This is known as diffraction. The Huygens-Fresnel principle models this. Huygens postulated that every point on a wavefront acts as a source of spherical secondary wavelets, and Fresnel developed the equation using the Huygens wavelets together with the principle of superposition of waves, which models the diffractions quite well. So I wasn't wrong by saying this was like Fresnel related, but it's the there's also Kirchhoff's law. Fraunhofer diffraction is models diffraction of the waves when plane waves are incident on a diffraction object and the diffraction pattern is viewed at a sufficiently long distance called a Fraunhofer condition from the far object in the far field region. Blah, 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 blah. In contrast, diffraction pattern created near the diffracting object is given by the Fresnel diffraction. Okay, so it's the opposite of Fresnel diffraction. That's the near field diffraction, and Fraunhofer is the far field diffraction. Okay, so that would be the aperture, and then this would be the diffraction. Anyway, I got way off topic with this. Let's go back to talking about volcanoes. This isn't off topic though, because this is wave related. You need to know what diffraction is if you want to know how all the waves do the things. Okay, Sakurajima exploded. That's why we saw it up there with those cool clouds. Suwano's Jima exploded. Canlaon in central Philippines also erupting. Explosive activity in Ibu, Samiru, Dukono, Home Reef in Tonga Islands. That is where actually in the area of a lot of active seismic activity. Songhai in Ecuador continues to explode. Sabancaya too. Let's see who else has popped up. Similar names. Everybody in the past few days. There's Lewatobi. Here's Dukono. Popo continues to explode in central Mexico. We've got volcanic ash warnings around there. Yeah. Currently erupting still, 38 volcanoes are being reported as actively erupting. Let's go now to check out our earthquakes. Okay, so we started with the earthquake in North Carolina. Actually, let me see if is anybody here. Nobody's here. That's okay. Started with the earthquake in North Carolina. We've got a 5.9 here just south of Cuba. That is 22 kilometers depth. Now, that's kind of remarkable because we don't often see earthquakes over here. We do often see earthquakes near Puerto Rico right here, but a 5.9 out of Cuba is pretty significant, and it is the most recent quake that has happened here. This is just off the coast of just off the southern Cuban coast. This is near an area of it's color coded to make me think this is like a wilderness area near Guama, Santiago de Cuba, Loma El Gigante. And so, yeah, Loma Gigantico sounds like a big loma, whatever that is. Probably could have been felt in Santiago de Cuba. Guantanamo probably felt this. If you were in Guantanamo Bay, you probably felt this. So that's interesting that they could have felt that earthquake there. It's in the very outermost region of earthquake feelings. Quite interesting. Wow. Yeah, that's fun. 37 miles south of Guisa, Cuba. Then we had in South America a 4.8 here in coastal Peru. We had a 5.5 in northern Chile at 0 kilometers depth. So that's a surface 5. 4.1 at 98 kilometers depth down in central Chile. Then also a 5.2 in the South Sandwich Islands, kind of near the edge where this is actually on the tip of that Antarctic island chain where that big iceberg just broke out of its Taylor column. What is it? The area where it was like an eddy out in the water that kind of spun it around all the time, that it just broke out of that holding pattern. This is kind of near where that happened. There's a 5.3 in South Africa. This is pretty rare. A 5.3 at 0 kilometers depth. There are surface 5s popping up all over the place where they don't usually go. 4.9 at 10 kilometers depth. Let's see. This is right on the border there of Zimbabwe and Zambia. The Zambia is on one side and Zimbabwe is on the other. And the lake that divides them is Lake Kariba. And this earthquake happened right in the middle of Lake Kariba. So that is pretty remarkable, I'd say. Very rare that we get earthquakes there. Very rare and, I mean, really interesting. We also had more African quakes here. Well, one was in the right off the coast of Eritrea in the Red Sea. It's kind of actually on an island that is part of Eritrea. I used to think it was Eritrea, but it's actually Eritrea. That is on the way to Sudan's coast, but it's not there. And it's not quite, Eritrea is between Sudan and Djibouti. And of course, everyone knows that Somalia has the Horn of Africa. This is an area that many people in the world would love to control. But not going to say much else about that. There was also a 4.6 here in mainland Eritrea. The 4.6 was at a 4.6 in the, this is the Great Rift Valley. Yep. In the Great Rift Valley, Nazareth, near Awashasab Highway. Let's see. Oh, no, this is Ethiopia, not Eritrea. My bad. This is Eritrea stops here and Ethiopia. This is their borderland zone. This is in the there's so many things here. This should be in the Great Rift Valley area. I don't know why when I zoom in on the map, I don't see the rift zone indicated. I have to go very far out. The Awash Wens is the river here that goes like all the way from this lake in Djibouti all the way over to like through the mountains, through the Great Rift Valley into Kenya. Really interesting. So, okay, do you kind of see the rift though? Do you see the big curved thing right here? This earthquake is definitely in the middle of the Great Rift Valley. So this is a less surprising area to get an earthquake in. Still very interesting to have fives all over the place, surface fives all over the place. A surface five also struck out here back on the 17th in the Mid-Atlantic Ridge. Let's see. A 5.1 struck on the solstice down here in Greece. We also had a 4.5 at 33 kilometers depth south of Crete, and a 5.2 at 10 kilometers depth, also south of Crete. There was also two 4.6s out here on the plate boundary between the African plate and the Indo-Australian plate. That was today on the 22nd. Nothing in the Himalayas, surprisingly, but look here. We have all those surface fives showing up on this side of the very active volcano map as well. 5.2, 5.0 at 10, and then 4.9 at 10, a 5.1 at 0, a 5.2 at 0. Some smaller quakes showing up in surface levels in both Australia, both ends of Australia. Also, a surface 5 on the Antarctic and Australian plate boundaries. Also, a surface 4.9 in New Zealand. Also, a surface 5, a cluster of surface 5s around the wave-shaped plate. This is the area where that 7 struck a little bit ago. Looks like we're having aftershocks of 5s ripple out from here, both at the surface and deep down. We're having like this 4.6 is 454 kilometers depth. That's where we're used to getting deep quakes. This 4.6 is at 570 kilometers down. That's where we're used to seeing the deep ones. But the 4.5 here, 533. But we're seeing a lot of surface 5s radiate out along with some deep 4.6s everywhere. Do we have a surface 5 here in? Yes, we do have a surface 5 in Alaska as well. So right off the coast of, let's see, the Kodiak Island region. There were 2 earthquakes here. One was a 5.2, one was a 5.0. Both reported on the 22nd today, one at 3:56 and one at 11:44 local time. And this is just south of that Kodiak Island area. Which is south of Anchorage. I wonder if people in Anchorage could have felt it. Really cool to see, scary, but cool to see that all of this global unrest happens simultaneously about a week after we get hit with a lot of solar radiation. Also got a decent stack of quakes coming out of California, but it looks like the area where the 6.2 hit has finally calmed down a little bit. We're only seeing like a 2 and a 3 out here, which is better than 5s every day. There's also huge clusters of quakes in specific areas like this weird Western Nevada area, the Geysers, California, places that we're used to seeing a weirdly large number of quakes. California is just like constantly moving and shaking, breaking, drying. It's like a brittle cookie, in my opinion. I just picture it being like a dry, crumbly, brittle biscuity cookie, and it's constantly doing these little tiny breaks instead of a really hard cookie that's very like dense and moist that you break it and you try to break it and it all of a sudden snaps in one big break. This would be like smushing a really crumbly cookie. It breaks into a bunch of little pieces, which is a little less scary actually. 2.2 over in the New Madrid seismic zone, and a 3.1 over here in northwestern Louisiana. That's at 5 kilometers depth. Let's see. That is west-northwest, 5 kilometers west-northwest of Mooringport, Louisiana. I don't know why they didn't just say near Shreveport, because Shreveport is right there. It's in the middle of Caddo Lake, Caddo Pine Island oil and gas field. Oh, near Oil City. It's in somewhere called the Longwood Oil and Gas Fuel and the Army ammunition plant out in the middle of a lake that is surrounded by oil and gas fields and an Army ammunition plant. Nothing to see here, folks. That's just a very normal earthquake. Let's go now to talk about our weather, our atmospheric terrestrial weather for you. Looking here at our winter weather radar product from Radar Omega, we can see that there's a decent trough ahead of the cold front and warm front that are spiraling related to this low in Iowa and Minnesota. You can see the stationary front and cold front kind of swooping things down, the warm front swooping things up. These are all spiraling, and it looks like there should be like a 5-pointed star of something. Yeah, you can almost see it right there. Can I draw? Yeah, it looks like there should be a star like that. Do you see the 5 points? Yeah, it looks like that. I forget that I have a draw feature on here a lot. I should use it. This banding, the way that the clouds are shaped right here, shows that your wind direction is your wind is perpendicular to the front. That doesn't look perpendicular. Perpendicular to the warm front here, going like that. Your wind will be perpendicular to the point in the clouds where they're bowing out. When it looks like that diffraction pattern that we were talking about earlier, that's usually caused by some really strong straight winds that are blowing the most straight and strong in that one direction where it is bowing out around from. Because it is like Huygens said, and every point in the wave front does create a new point source of a wave, and it all bows out from rippling upwards and downwards. Okay, enough of that rant. Let's go to reflectivity. And it doesn't even look that productive on reflectivity alone, but any of this that does produce winter weather would be snowy or mixed precipitation. I think especially once this warm front moves across the Great Lakes, Lake Michigan area, it's picking up a little bit more moisture, bringing it more into Canada too. On the back side of it, we do have some mixed precipitation coming down from North Dakota into South Dakota. We've also got some decent precipitation for how cold it is out near Wyoming and Colorado. And there is a very healthy looking, well, not very healthy looking, a very aligned front coming in on the Pacific Northwest. We've got a cold front bringing all of this air mass onto like the exact curvature of this armpit of the Pacific Northwest is what I call it. I just think this looks like an armpit up here, like Canada is an arm and Alaska's a fist or something. Like this is really the armpit. This would be like, I don't know, maybe the curve of the stomach. Anyway, the front kind of hugs the coastline here, and that throws all the moisture up onto here. Let's take a look at our web satellite. Look at our upper level water vapor. Oh, it doesn't show much. Lower level. Yeah, that'll do. You can see kind of, you'll be able to see the lines of fronting in here. Okay, look at that. That is all slamming up against the coast. This is where we've landed with it. This is the cold front bringing in that moisture. This is the moisture coming from lower in the atmosphere. I wish this had a different, can I pick? Yes, I can. I want to pick Pacific. Yes, that's what I want to see. Okay, thank you very much. Let's look at the Pacific Basin because that'll show us a better flow of how this is coming directly from Hawaii. Up here, spiraling. This is the low right here. This is the spirally boy, the spinny boy that is sucking all this moisture from the Central Pacific into Seattle, Portland, Vancouver area. Now this is dry, cold air. Kind of, this is where the cold front is the drier, colder air. The warmer, moister air is like they're laminated. They're in like cinnamon bun type arrangement where they're spinning around each other. Not really diffusing, but layering so frequently that it's not a gradient anymore, and it eventually gets, you know what I mean, how mixing works. It's folding in. Like if you were doing a dough, if you were making a dough, this would be the folding in of the layers. And you can see that that's throwing a lot of moisture at Northern California again, which has already seen its fair share of rainfall, but they're probably dealing with even more again now. And that is also helped out by this high pressure system here that keeps it on the more northerly track instead of getting to Southern California. Now, let's go back to continental US, or CONUS, as they refer to it. Sometimes in my dreams, I go back and visit the school where I learned meteorology, and I imagine that it's very different, but that people still know who I am. So we can see this system below. What's getting shirked away by that high pressure system out there is what's feeding all this moisture. So we'll have a new wave of moisture after this low system comes in. Highs here. It's looking less and less like a white Christmas for my area. Sadly, I wish this were moving into the area where there's high pressure, but unfortunately that's not how it works. High pressure air moves from areas of high pressure to low pressure, not the other way around. So it's escaping the high pressure zones to the low pressure zones. It's going to be harder for these low pressure zones to displace the high. So that sucks. Let's look at I don't know what the fuck these ads are. Let's look at pivotal weather. Just take a look. Oh God, I'm running out of time. It's late. It is late. Precipitation. So yeah, we already see the effects of the precipitation in just 6 hours. They've already got an inch up here in Vancouver Island. They've already got like up to half an inch in parts of the Northwest. Really not much precipitation to speak of in the rest of the U.S. in the past day. Past 3 days, we had precipitation up in the Northeast, and I can speak to, there were some flurries over the weekend here, but nowhere near as much rain and snow as we got in the past week. Now, let's look at hazards. Not looking too hazardous. A few areas where there's some winter storm warnings, and that's it. Let's look at forecast snow in the next 2 days. Yeah, looking unlikely for me. Ice, no. Actually, temps in 3 days, looking to be in the 40s and 50s. Probably not going to support a white Christmas, unfortunately. I wish there would be some flurries or snowfall somewhere in the Appalachians, but it looks like just the far north Appalachians are going to get it. Also, everybody in the mountain states, up in the higher elevation of the mountain states, you're probably going to get a white Christmas. That's fun. That's nice for you. Michigan, you're looking at Michigan and New England, you're looking at a white Christmas, but not us. Okay, let's go next to what comes after the atmosphere. Oh yeah, the sun. Let's see, geospace, magnetosphere movies. All right. Magnetosphere movies. Okay, so this is what the magnetosphere looks like right now. You can see the flow of, whoa, look at that just happened. That was a big hit. That's a decent chunk of, and it caused that backwash. Do you see it? When we get a big blast like that, it also causes some in the magneto tail to go backwards and possibly precipitate downwards. Let's see what that's looked like on density. Ooh, really low density. Really low plasma density around the Earth here. Only like in the tight circles, and then just a big old wave of plasma happening. Big energy bursts going down there. Let's look at the pressure. Look at this, extremely low pressure, just a nice band of protection around the Earth, like circularly. This is a torus around the Earth. And then boom, dang, all this pressure going around. Let's see what that is from. Let's look at let's see what that's done to the Schumann resonances. I'm going to check these in a few days. Ooh, looks like we had a really active day on the solstice, and not too much since then, but not quiet either. Decently high energy dispersal across all of them. Let's see the report from spaceweatherlive.com. Maximum X-ray flux of the past 2 hours is an M1.09. We had a M1.9 on December 21st, an M2.5 and 2.1 over here. Let's see, that's some decent ones. We've had some increasing X-ray flux activity. We've also had, wow, look at all these CMEs today. From 40 to 56, that's 17 coronal mass ejections in one day. That's huge. And then yesterday, we also had a lot of activity yesterday too. And this is probably that geomagnetic storm that we saw on the magnetosphere movies. We reached KP4 index, meaning active solar storm conditions, active geomagnetic conditions observed. There was a R1 radio blackout in progress. There's a M1.05, 1.09 flare, radio blackout, solar flares. Okay, so let's take a look at the solar flare from yesterday. That was a big one, and it looks like there's some elevated solar protons here too, that black and white dots. Big old sun farts. And that's a big one getting ready to go. Let's look at this one. That's the one that was getting ready to go, and it went. You should go. That's how it sounds. Imagine the sun sounds like. Yeah, wow. Look at all that activity. Let's see. That is because we've got all these active condition areas. This is, is this gonna, no, this gives me the old one if I click it. But the new one is the one we see here with this bright region and this bright region. 3932 and 3928 are looking complex. I would think that these are all one region, but I guess they don't think that. We do have beta gamma type regions. Okay, and we do have elevated solar protons right now. Let's look at, wow, that is decent. I bet that is from, that happened when we had, let's see what that is from. See if we've got solar protons, solar proton flux. Okay, so looks like this radiation storm started on, okay, so last time I talked to you on the 17th, we had this little spike, right? But then things started growing and growing and growing. And then we have now reached just below the 10 mega electron volt warning threshold. But I would say that since we have such a long volume, like a long area of times of solar radiation right now, that I would consider this a proton storm because we have so much area under the curve. There's a decent chunk of protons coming at us. This is based on the flux level at any one point in time rather than the total amount that's gotten in. Yeah, we got to wait for the warning threshold for the 10 mega electron volt range, but we did peak out at 4.54, and I think we have to get to 10 particles per cubic centimeter per second per steerad, SR, I forget what that is. Steerad. Oh, I was right. Steerad. Protons per centimeter squared per second per steerad. There's a higher likelihood of impact on a sensitive location. Okay. So these higher energy particles can access the polar ionosphere and create an enhanced region of ionization called the D region, which interferes with HF radio communications in these areas. So high energy particles can reach the Earth anywhere from 20 minutes to many hours following the initiating solar event. So these flow way faster than plasma or coronal mass. This is stuff that's getting to us pretty rapidly. This is radiation. So if your iodine, thyroid hurts, there may be a reason why. Maybe eat extra seaweed. Okay, that's neither here nor there. Far side of the sun looks super active. Earth side of the sun also super active. There's no shock that we've gotten so many coronal mass ejections right now. This is a pretty decently active sun right now. I know there was talk that maybe the sun has passed solar maximum, but I don't think so. I think it's still possible at any time for us to get a big increase again. Also, it is near the equinox or the solstice, which is a time of evening in the Earth's tilt away or towards the sun, and also a peak so the winter solstice is when we are closest to the sun, and the summer solstice is when we are furthest from the sun. You can remember that because like the northern hemisphere gets it the least, like we have the opposite of like when you would think it's cold when we're far from the sun, but actually we're closest to the sun in winter time. So for the northern hemisphere, for the southern hemisphere, it is the extremes of they're the farthest from the sun during their winter. Interesting disturbance storm time indexes looks like decent disruptions happened. So that makes a lot of sense. Had a lot of huge proton density up to 22.91. That's per proton density or plasma density per cubic meter, I think. Damn. We got high hemispheric power. I mean, the KP index has been higher previously and then gone down. Like in the past 2 days, not getting... Oh, come on. Why won't you load? There we go. So we got up to KP4 yesterday and today. Just a few hours ago, actually, we were at a 4, and now we've gone back down to a 2. Okay, let's go to the planetary weather. Planetary weather, we have passed the solstice, so we are now in Capricorn season. The sun is in Capricorn, which is the first time the sun's been in Capricorn without its Pluto shit going on in a while. We have Mercury still in Sagittarius, but now direct at 10 degrees of Sagittarius, now applying to its second round of Jupiter oppositions. Jupiter is still in retrograde in Gemini, but this time the newly direct Mercury will have maybe a little bit of the upper hand. Maybe there will be more of a mercurial slant to the way Mercury expresses its power in Sagittarius, fueled by this retrograde, a little bit debilitated Jupiter retrograde in Gemini. They are in mutual reception still, but they're not both in retrograde anymore. Only one of them is. Saturn in Pisces is direct at 13 degrees of Pisces. That's going to be direct until it moves into the first degree of Aries next year, which is coming up. Don't ask me about 2025. We got a Libra moon right now at 5 degrees of Libra, and we are in the last degree of the nodes being in Aries and Libra until we switch into the nodes being in Pisces and Virgo. So our next eclipse cycle will be in the Pisces-Virgo axis. Saturn is moving into its square with Jupiter. Saturn-Jupiter squares are harsh, tense, part of a big Saturn-Jupiter cycle in the cosmos. Venus at 18 degrees of Aries is very benefic. I think giving a little bit of a fun, flirty look at the future. Not exactly as fun when that is sextile to Chiron, and a Chiron that is opposite Black Moon Lilith and Libra, but still doing pretty well, I'd say. This will be a T-square between Jupiter, Mercury, and Saturn when Mercury reaches 14 degrees of Sagittarius. So we're gearing up for that. Probably going to be a lot of talk about limits, boundaries, expectations, abundance. People probably going to be talking about their philosophy about abundance and lack a lot, and whether they think it's possible to manifest things and what they think the nature of reality in this plane is. I certainly could talk about that stuff a lot. But, I never switched us out of weather mode. I've been thinking in the winter times, the winter hours, days, about the nature of reality and how you can co-create reality and how we all do that and how you can manifest abundance. And wow, I'm just going to say things have been really proven to me that you really can just ask for what you want and need and get it if it is in your highest interest and you truly, genuinely have put forth some work for it. So I do believe it is possible to manifest things. And with that, I think I'm going to switch to our vibe reading. It's a good note to start talking about energies with. Okay. There we go. Let's see. That's a nice selenite sound. Very pretty, very pretty. Okay, what is the vibe of today? What's the energy coming in from the planetary, beyond the planetary, from the etheric and beyond sphere? By visualizing my desired outcome, the perfect action is always inspired. And it's got the moon looking at a field of white roses, which is beautiful and also exactly what I was just talking about, manifesting. As you desire to feel As your desire to feel good leads you to thoughts that feel good, the perfect action will be inspired from that alignment. And that inspired action is always joyful. Beautiful. Let's pull a tarot card for that. Who's going with this one? By visualizing my desired outcome, the perfect action is always inspired. All right, we got the 9 of Pentacles in reverse. So maybe a limiting of our material abundance, maybe a limiting of the feminine ruler of our earthly domain. Where are we holding back our nurturing? Where are we holding back nurturing ourselves, the other, the world? Where are we shy about sharing our abundance? What is the inner quality of Venus as well? Perhaps this solstice, you've found yourself in a place of abundance and you don't really know what that means, how to sit with it. You're probably in the visualization step of figuring out what the perfect action is. You've got to do the reflection of the results, reflection on the results, to figure out what the next right thing is. Now for the liminal space. Just passing through, and it's got a Luna moth. Interesting. Let's see what just passing through says. On one hand, the entirety of life could be viewed as a transient phenomena. On the other, perhaps you are just meant to ride out this particular trip with as little attachment as possible. You will be gone from this moment soon, or it will be gone from you. Try to enjoy. Savor the joy. Savor the ride. You're on a machine that does the manifesting thing. You're on the ride to enjoy the feeling of that. So just ride it out, like it, enjoy it. Maybe become a little bit less attached to the permanence of things of this world. Maybe that's how you can be a more agent of abundance, is being less attached to the things of this world. All right. That's it for today's weather tonight. I love you guys. Have a great evening. I will see you tomorrow.